Hi, 7th graders, Miss Opp here. Today we're going to be learning about the Pythagorean Theorem. Our learning objective for today is I can use the Pythagorean Theorem to find the missing side of a right triangle and determine if a triangle is a right triangle given the three side lengths. Lots of words for today's vocab. The Pythagorean Theorem is in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. You can just write Pythagorean theorem is a squared plus b squared equals c squared. Legs are the two sides of a triangle that form the right angle, so I'm going to highlight those in yellow. The legs would be A, oh that's kind of hard to see, and B. Alright, A and B here. The hypotenuse is the side opposite the right triangle, or the longest side of the triangle. So, looking, I will highlight that in green. C is the hypotenuse, because it's opposite, it's directly across from that right angle. I'll write C here. The highlighting is hard to see. The converse is just reversing that Pythagorean theorem. So, the Pythagorean theorem is one of the most famous theorems that are out there, super famous, and it is credited to Pythagoras. That's why it's named the Pythagorean theorem, because Pythagoras was the founder of the theorem. So, looking, we know that the Pythagorean theorem is a squared plus b squared equals c squared, but let's find out how that was discovered. So, over 2,000 years ago, Pythagoras made this amazing discovery about triangles. When the triangle has a right angle, so the Pythagorean theorem is only a right triangle, and squares are made on each of the three sides. So looking at this picture up top, if I were to make a square of the length b, B would also be on that side. If I would make a square of side A would also be on this side. And if I made the square of C, the length C would also be right there. If I do that, then the biggest square, so in our case C, has the exact same area as the other two squares put together. So looking, if I found the area of this square multiplied a times a, I would get a squared. If I found the area of the purple square, I would do b times b, which is b squared. Those two added together would equal the area of c squared. The area of the red box, c squared, a squared plus b squared would equal c squared. Pretty cool, huh? So that huge big concept is called the Pythagorean theorem. And it can be written in one short equation. A squared plus b squared equals c squared. Make sure you have this written down once, if not multiple times. Okay, the formal definition of the Pythagorean theorem is the longest side of the triangle is called the hypotenuse. So hypotenuse is going to be labeled C. The two shorter sides are called legs. A and B are the legs. So the formal definition is, in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Basically, a squared plus b squared equals c squared. Down here, I included just a visual picture of the hypotenuse and the legs with that definition. If you think you're going to have a hard time remembering, draw this picture. Okay, then also just the key concept definition of the Pythagorean theorem. It's saying the same thing that I just told you. So, you're probably wondering, why is this useful? You can use the Pythagorean theorem to find the length of a side of a right triangle when you only know two of the other sides. So basically, we can find the missing length of a triangle using the Pythagorean theorem. We want to write an equation to use to find the length of the missing side of a right triangle. Then we're going to find that missing length. They want us to round to the nearest tenth if necessary. So, right off the bat, we know that the Pythagorean theorem is c squared equals a squared plus b squared. Okay, looking at our triangle, we have the two legs of our triangle are 9 and 12, and our hypotenuse c is unknown. So I'm just going to go through and label these with my letters, and so I know what I'm going to plug in where. A and B. Plugging in those numbers into the Pythagorean theorem, into our equation, we have c squared equals 9 squared plus 12 squared, which then evaluating both of those exponents, we get c squared equals 81 plus 144. Continuing on with this equation, adding those together, we get c squared equals 225. And then by the definition of the square root, we know that we can take the square root of both of these to undo that exponent, because they cancel each other out. So c equals the positive and negative square root of 225, which we get c equals 15 or negative 15. By this definition of a square root, that is going to be a positive or negative number. But we know that because we have a physical triangle, it cannot be negative, so the hypotenuse must be 15 inches long. So let's try another example. In this one, we are looking for B, we're looking for one of the legs, and we know what the hypotenuse is. So first off, I'm just going to go through and label A, B, C. And so I know what I'm going to fill in where. Our Pythagorean theorem, again, is a squared plus b squared equals c squared. And plugging in our known numbers, a was 8 and c was 24. So 8 squared plus b squared equals 24 squared. Evaluating those exponents, we get 64 plus b squared equals 576. And we want to solve just for b. So, reverse PEMDASing, doing our multi-step equations, we're going to subtract 64 from both sides, which will leave us with just b squared equals 512. By the definition of the square root, we can take the square root to both sides. That'll cancel out that exponent. And so b is the positive or negative square root of 512, which when we use our calculator to find that, rounding it to the nearest tenth, we get b is about 22 6/10, or negative 22 6/10. But a side length always has to be positive, and so b would equal 22 6/10. A quick little study tip that's really a good idea to think about is that the hypotenuse, c, is always our longest side in a right triangle. Since 22 6/10 is less than 24, that is a reasonable answer for b. If we had gotten the answer of b equals 26, we automatically would know that's wrong because c, the hypotenuse, has to be the longest side in a right triangle. Okay, let's try a couple more here. So, using our Pythagorean theorem, a squared plus b squared equals c squared, let's solve for c. I'm going to label a and b, and so I know what I'm plugging in where. I have 18 squared plus 24 squared equals c squared. Evaluating those, I get 324 plus 576 equals c squared, which equals 900 equals c squared. By the definition of a square root, I can take the square root of both sides to undo that exponent. So I get c equals 30. And checking for reasonableness, the hypotenuse has to be the longest side. and 30 is the biggest number out of the side lengths of this right triangle, so this answer makes sense. Looking at B, we have 3 miles as the leg A, B is our unknown, and C is 8 miles. So, plugging this into our Pythagorean theorem, a squared plus b squared equals c squared, I'm going to have 3 squared plus b squared equals 8 squared. Evaluating both of those exponents, I get 9 plus b squared equals 64. Reverse PEMDASing using my train tracks to get b squared by itself, I'm going to subtract a 9 from both sides. And I will be left with b squared equals 55. By the definition of a square root, I'm going to take the square root to undo that exponent. And I will be left with b equals about 7 42/100ths. Which, checking for reasonableness, 7 42/100ths is less than the hypotenuse length of 8. So this is a reasonable answer. Another tool that we can use the Pythagorean theorem for is to identify if 3 side lengths form a right triangle. So if we reverse the parts of the Pythagorean theorem, you have formed its converse. The converse of the Pythagorean theorem is also true. So if the side lengths of a triangle have lengths A, B, and C, units such that c squared equals a squared plus b squared, then the triangle is a right triangle. So if you take 3 side lengths a, b, and c and plug them into the Pythagorean theorem and it's true, then that triangle is a right triangle. Let's try an example of that. The measures of 3 sides of a triangle are 5 inches, 12 inches, and 13 inches. Determine whether the triangle is a right triangle. So, looking just right off the bat, I know that A is going to be 5, B is 12, and C is 13. 13 is the longest length, and so I automatically knew that that was my hypotenuse. And I like to do the smaller size for A and then the slightly larger leg for B. Personal preference. You can rearrange A and B, still get the same answer. So, plugging those values in, I have 3 squared. Does it equal 5 squared plus 12 squared? Evaluating those exponents, I get 169. Does it equal 25 plus 144? Just evaluating the rest of that equation, I get 169 equals 169, which is a true statement. And so this triangle is indeed a right triangle. Let's try one last example of identifying a right triangle. We want to determine whether the triangle with the sides of the given lengths is a right triangle. Our side lengths are 4, 7, and 5. For me, I'm going to draw a picture just to help me visualize this problem. So we're hoping it's a right triangle, so I'm going to draw a right triangle. 7 is the longest length, and so that's my hypotenuse. My shortest side is 4, so I'm going to put that on the shortest side. And then that kind of mid leg is 5, so I'm going to put that right here. So now I have a visual that I can look at. Knowing the Pythagorean theorem is a squared plus b squared equals c squared, let me quick just label these. C equals 7, A equals 4, and B equals 5. So plugging all of those in, 4 squared plus 5 squared equals 7 squared. Evaluating all of those exponents, I get 16 plus 25. Does it equal 49? Because we're not sure, so I have to add those question marks. 16 plus 25 gives me 41. 41 equals 49 is a very false statement. Super false. So is this triangle a right triangle? No, it is not. Don't forget, for better understanding, you can rewatch this video, you can read the examples in the book, you can YouTube the topic and watch other videos on it, and as always, ask questions. Your next step is to go take the video quiz on Schoology. Here are the instructions how to get there. We are on section 3-5. Happy quizzing!